So we've got, what, 5 or 6 different pendular systems. And you don't call them A, B, C, D, E, right? This is A or something like that. This is B, C, D, E, and F. Now the key thing, though, is just one key equation, right? You're trying to say rank according to the number of complete cycle motion of each pendulum goes through, rank from least to greatest. You're trying to find what? Rank the pendulum according to the number of complete cycle of motion of each pendulum goes through. So they're looking for the change in the period. So T is 2 pi square root of L over G. Now, if you think about it, the only variables that we can change, well, the only variable is the length. So when you get to like part B right here, and he's got 4 kilograms versus A, which has 2 kilograms, the mass has no difference. But the length does. So if you take the square root of 1 for letter A, that's 1, the period, let's say, is 1, okay? But then for part B right here, you have the length of 4, so square root of 4 is 2. You get the idea? So you're going to rank them in order from the lowest period to the highest period, and it's all about the length. The rest of the stuff, the mass, has no bearing on the thing. And also, as a note, I guess the angles are all the same. If I change the angles, guess what? Angle's not in the equation either. So if I swing it back further or lesser, it won't make any difference. So it's just square root of L is proportional to.